Hello, everyone. Welcome to another session of Data Science and AI in Africa. Today, we have Tanya from Kenya, who is in research at IBM Africa. Hello, Tanya.
Hi. Hello, everyone.
Thank you for making time for this. So we're just going to get into your journey into data science, and then we'll talk about research, and then maybe you can give advice for people who want to do research in data science, maybe who are looking at IBM Africa as one of their choices. So can you introduce yourself and talk about your journey into data science and AI?
Okay, thank you very much, Satenda. My name is Tanya Akumu. I am an AI research engineer at IBM Research Africa. We have a lab here in Kenya, and I'm in the Trustworthy AI sciences team. So we do research in trustworthy AI, looking at themes such as robustness, anomaly detection, and fairness in artificial intelligence systems. So before I joined IBM, I started out my career as an electrical and electronics engineer. I did my undergrad at Jomo Kenyatta University here in Kenya and majored in electronics engineering. And then afterwards, I worked for a few years in hardware. So I became a hardware engineer. I was mostly looking into designing electronics for pay-as-you-go solar home systems. And as I did the work in IoT, it was mostly IoT on the edge side of things. We encountered a project whereby we had to make our devices, we had to add some kind of intelligence to our devices, whereby we wanted to know how the battery of the device is faring on while it's with the customer. So we needed to make it tell us how it's charging, send us some parameters, and then from that data we analyze it and then now provide remote monitoring and predictive maintenance to our customers. So in the process of that project, when we had data coming in, it was technical data, and they had a lot of data scientists, but these data scientists didn't really understand the technical data from the battery. So if the battery is sending parameters such as current or voltage, how do you know what's good and what's bad for the battery? So they needed a technical advisor to come in and help them with the analysis of the data, which is where now I came into the project to help them identify faulty batteries or to try and understand how the battery health is going on. So while I was now working with the data scientists, I became very interested in the field itself, and I decided to pursue a master's in electrical and computer engineering at Carnegie Mellon University. But now I concentrated or majored in applied machine learning. So we had, I mostly focused on data science courses and applied machine learning and deep learning. And then afterwards, that's when I now moved completely to AI and machine learning. I was able to apply to IBM Research Africa, did the interviews, and I was able to secure a job there. So since then, I've been in IBM, I think for a year or so, and I'm still continuing with the AI research.
Oh, that's quite an interesting journey. So how do you move now from what you were doing in applied machine learning into like trustworthy AI? Because that sounds a little, it's still AI, but it's a little different.
I mean, I wouldn't say it's very different, because like the trustworthy AI you're basically applying machine learning, or rather you are still applying the machine learning systems in this trustworthy AI systems. So for example, one of the things that we are looking at is in subset scanning, anomaly detection using subset scanning. And what we want to use that for is trying to find a systematic way of detecting deviations in models and in data. So for example, if you're now looking at a model, you have built an AI, you have built an ML model and it's making your predictions, but then there might be some subsets of data that are being biased against by the model. So there's still the application bit whereby, yes, you make the model robust, but then we then now come and see, we want to find out which part of the model or which part of the data is the model biasing against. So we would find that, okay, maybe for these predictive models, we have this feature agenda, in the gender we have females, and females are being biased against for a specific, like for example, if it's a predictive role of maybe giving jobs in the tech industry, and then we find that some women are not being able to recommend it for the job because the AI, the ML system has learned that not many women are in that field in particular. So, and sometimes like these themes in Trustworthy AI can be applied to the model itself. Okay. Right. So it's not necessarily like deviating away from the applied machine learning. We're still using the applied machine learning, like building models for specific domains, and now then applying these trustworthy themes into the models that we have built.
Okay. So how would you define trustworthy AI to someone who doesn't know what it is?
Okay. So I would say trustworthy AI is kind of trying to build systems that are, I don't want to use the word responsible, basically, but as the ones who are building these systems, right? We have to make sure that we are building a coherent system that is fair and will not come and add more challenges or more issues to the problems that we're trying to solve. So trustworthy AI comes now to now explain this, or rather to try and shed light into what responsible AI means. One aspect is on fairness, whereby we want a model to try and to be fair in terms of how it's giving predictions. One of in the data protection policies that have come up in the recent years, one of the requirement is that if you're using an AI to make predictions, then so for example, if a bank is employing an AI system to recommend who to be given a loan or who not, like the people that are affected by it have a right to explanation. So the model needs to, or not even the model, the people need to be able to be explained why they were not recommended or why they were recommended for getting a loan. And for these AI systems or the models, machine learning models, they're usually seen as black boxes, whereby you just give it an input and then it does its own thing, and then we get an output in the form of predictions or whatever other output we're looking for. So part of trustworthy AI is trying to first make those predictions fair, not by making sure that some of the features that are there are not being under-risked or over-risked by the models. Second is the aspect of interpretability, like we are able to understand how this output is coming about. So it's not just, we don't exactly know how the model is working, like we need to understand how the model arrives to its decision, and through that interpretability, we are able to now build more robust systems ourselves. So yeah, in a nutshell, I would just say is trustworthy AI is basically just putting in, and not just in models, is putting in the responsible AI, not just in models itself, but also in how we look at data, trying to make data less biased so that the model is able to learn on unbiased data.
Okay, that's a really good and clear explanation. So now, getting more into your work at IBM, what does a researcher do? Because I mean, I didn't even know that research could be a career, like before when I was doing my undergrad. But then later on, I figured out that people can actually work as researchers. So what does a researcher do, also compared to someone working in industry?
Right. Research is basically what we know as research. There's a problem that you're trying to solve, and you apply research methods to solve the problem. So specifically for AI, how research looks like. So for us, we basically have like themes or pillars which we focus our research on, and like I said, I'm in the AI sciences team whereby we look at trustworthy AI. So meaning we only focus our research in trustworthy AI concepts. So this could be applications. It could be applications like we work with various applications like in healthcare or in climate, but our focus is not in the application itself, it's in the trustworthy element of the project. So there are other teams that maybe are domain specific. They're only looking in themes like in climate or in discovery. So basically, we look into themes, problems that are of concern in trustworthy AI, and we dig deeper through researching. So we have to come up with papers. So we write papers, we build prototypes, and sometimes this ends up into building toolkits which the company can open source, so that the community can also be involved by using these toolkits. So I think one of them that we've built is the AI Fairness Toolkit, which came the AI Fairness 360 Toolkit, which is an IBM toolkit for fairness. And it's open sourced and it's out there so people can use. But that came out from specific research that has been undertaken over the years. So looking into so from the papers that are published, so when you publish papers, you've done your experiments, and your experiments can look like getting data and testing out. If you're looking at models, you're testing out models in various data sets. And this code should also be like reproducible in terms of either the experiments should be reproducible, so that if someone else is trying to replicate the work that you've done in your paper, they can read through it and implement it themselves. And then, so it's mostly just being involved in, we do write code, which is part of where the experiment in. We build modules that do whatever we are researching on, and then so the only difference with industry is that it's not like really engaging in terms of continuous, like every day you are coding. You might code every day, but then there's also elements of documenting your research, your experiment results through paper writing, through patent writing, and also being involved, like working with the now research scientists who are the ones who lead the research project itself. So as a research engineer, I do the engineering bit of building the prototypes, working with other engineers to port the prototypes into toolkits if we are getting to that part, and working with the rest of the engineers into porting research prototypes into company products.
Okay.
So, but it involves the whole thing: code writing, paper writing, patent writing, all that.
Okay. So one of the things that I realized while doing research is it's not really different from being in school. Like you do a lot of studying, like reading around. Is that the same for you?
Yes, I think that's a normal part of research itself. You have to read a lot. You have to read a lot in terms of what is being done out there and trying to find gaps, which you can say that you're contributing to, and that requires a lot of reading. It requires a lot of learning as well, because you'd learn how to use, maybe if you're building your own toolkit, like you want to compare what you've built with whatever is out there, then you'd have to learn how to use them, and then be able to make a comparison with what you are building so far. So it's always a learning curve. There's no time that you'll say, you sit down and say, okay, I know everything, because that's what research is. It's like today you say you know everything, tomorrow Facebook has published a new model that has all this, and you want to apply that model maybe to your experiments and extend it maybe with one of the themes that you're looking at. So you're always constantly on your toes in terms of learning, understanding what research it is you're doing, how you're contributing, and formulating that part to now present it to the technical community out there so that they can also learn from you. So to me, that's what I find exciting about my job. Yes, it does feel like school, but then you're getting paid for it. No one pays you in school, so you're getting paid to learn and produce some really high value and meaningful work as well. Yeah.
Oh, that's a good take on it. So, one of the things about these top tech companies is when you're doing interviews, there's stages and stages of interviews. Was that the same experience for you?
Yep. Yes. It's a very long and painful process. I think I don't know, I would say it's just standard across all big tech companies, but what I learned was just doing your best in every stage. As long and as dredging it is, just for whatever stage, always just do your best, always stay optimistic up until you get the email of whether we cannot continue with you or we continue with you. You always just give it your best. But yeah, for me, it was a long process, very long.
Yeah, I can imagine. So I've seen some people who wanted to, maybe they were selected for interviews at companies like Facebook, IBM, in fact, and they were asking about how do I prepare for a technical interview? Do you have any tips for that?
Yeah, I think I can share a few tips. Well, one thing you'd need to understand the role that you're applying for, a lot of this, a part of this is understanding the job description that was posted along with the role that you're applying for. So in the job description, they will say what work you'll be doing, which tools is required, which programming languages are required. So make sure that you at least know some of these tools that they're requesting you to do. And then also prepare technically. So if you've done any projects that can speak on your technical ability, be able to explain them during the interviews. So sometimes there's soft interviews whereby it's a technical interview, but you explain your technical projects. It's not necessarily like a live coding session. So for this kind of interviews, I would advise that you go deep into the technicalities of your project. Talk about the problem you're trying to solve, how you solved it, what tools you used, why did you use those tools, what challenges you faced, how you fixed those challenges, what you could do better after doing the project. And then there's some live interviews whereby you have to do live coding. So for this live coding, whether it's live coding or you do a coding test using one of these IDEs, you would have to prepare beforehand. So sometimes the job description says it requires data structures and algorithm knowledge. So make sure that you're able to solve problems and understand the technical case, like in terms of if it's data structures, which ones would be good for optimization. So for those kind of interviews, you need to really practice a lot of problem solving questions, and you can find them on LeetCode. There's HackerRank, there's Codility that can help to build your problem solving capabilities in code, and just practice as many times as you can. And then in the interview, just relax. No one is out to kill you. Just relax and answer the question, understand the question, make sure you read and understand the question, and then communicate. One of the things that I've seen people do is not communicate, especially when they're given like a code challenge to do. Someone would read the code and then immediately start read the question, then immediately start coding. But it's good to communicate, especially if you'd be required to work in a team. Communicate how you've understood the question. Communicate how you want to solve the problem, and then start coding and engage the interviewer in your coding process. And afterwards, the interviewer would ask questions based on what you do, and just keep communicating till the end. Like that's a lot of this. Soft skills are not really practiced in such because people think that, okay, I just need to get the answer correct, when sometimes it's not really about the answer, it's just how you present yourself. And as long as you can show that you have technical prowess by communicating and interacting with other team members and talking about how you solve the problem and all that, I think you should be fine. But there's also a component of luck as well. You might do everything right, but you might be lucky, you might not be lucky. But in all things, just stay positive and do your best. I have not seen anyone struggle or suffer if they've just done their best and stayed positive.
Okay, that's really good. So what advice would you give to someone who's interested in research in AI?
Mm-hmm. So one thing I can say is to just continue staying up to date with the research aspect in AI through these articles that are published every day about specific or about very different topics in AI research. So just keep yourself up to date with the current research. I would also say, like, do some projects, have some solid technical projects. If you don't have work experience, then the technical projects would help vouch for your technical ability. If you built a project using a specific language, it's something that they can see, okay, you can learn. It shows proactivity on your end to go out there and do your own independent work and do a good job at it. And if you have somewhere you can showcase this, like on GitHub or somewhere, a code repository somewhere, that would be good, because someone can go and actually see the quality of code that you've written. And also just apply to as many roles as you can, engage with professionals in the field who are in the area. So and also just do internships. So for example, like at IBM Research, we usually have internships, summer internships for master's level and for PhD level students. And we also have one for local interns. So if you're able to engage with network, like in a professional network, that you can be able to hear about these opportunities and apply for them. And if you're able to like get an internship at IBM, like that internship can turn into a full-time role when you're done with your studies. So it's an easier way to enter than just applying for the role without knowing without knowing anyone or anything about the company. So I think that's what I would advise people. Stay in touch with latest research in the area, read a lot articles that are published, keep practicing, work on projects, and apply to opportunities that you see, and keep in touch with professionals in the network that would expose you to other opportunities in the field.
Okay. Thank you so much. Thank you for making time for this. I'm going to stop the recording now.